Natural logarithms, remember, involve e as base. That's what they are. So e, Euler's number. Euler's number, we discussed this a little bit yesterday, was also called the natural base. And that's the reason that these get called natural logarithms. I don't like that screen not showing you everything, so hang on one second. There we go. Sometimes the auto hide decides not to work. So, our objective, same as yesterday, is to evaluate and simplify natural logarithmic expressions and to solve equations using natural logarithms. And that's the rocket science we're going to do today. We're actually going to use equations with natural logarithms to solve. So we are way down here where we see the space shuttle. And natural logarithms are useful because they help express many relationships in the actual physical world. We had talked about how he found this number by trying to charge people interest all the time. And he noticed that there's a limit. His number 2.718, blah, 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 showed the limit of that cutoff. So here we're going to use natural logarithms. It says a spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. So here's the deal. Got to have a lot of oomph to get out of Earth's orbit because gravity holds everything back. So they're saying if you want to be able to get to orbit, you have to make sure you can reach that velocity of 7.7 kilometers per second. The formula for a rocket's maximum velocity in kilometers per second is, look at that, it has an ln in it. So negative 0.0098 t plus c ln of r. Great. Now we just need to know what all those variables stand for so we can put stuff in for them. It says the booster rocket fires for t seconds. If you've ever watched this, it takes it a while to get going. You watch it, and this booster rocket that's below it is called the booster rocket because it gives it that extra little boost when it first starts up. But then it falls off because they don't want the booster rocket on there taking up energy the rest of the trip. So that booster rocket fires for t seconds to give it that extra oomph. And the velocity of the exhaust actually helps push it up too because all of this stuff is spewing out of that rocket and it forces the rocket up. So the ratio of the mass of the rocket filled with fuel, because obviously they have to have fuel in here somehow, to its mass without fuel is R. It's going to burn fuel, so it's going to get lighter as it goes up. Suppose the rocket shown in this photo has a mass ratio of 25, a firing time of 100 seconds, and an exhaust velocity of 2.8 kilometers per second, just as it says over there. Could this space shuttle, attain that stable orbit? Well, we need to know if its velocity is 7.7 or higher. So we go back to our little formula, and we just have to find the numbers that go in for all of the variables. Because ln is on our calculator. We're just going to be able to punch that all in. So here's our job. We need to know t for this space shuttle. Let's go back and see if they gave us that. It said the booster rocket fires for t seconds. Let's see here. A firing time of 100 seconds. And I need to know what c is. And c says the velocity of the exhaust. Yeah, I don't like that they used c there. I suppose we could think c for cloud, because the exhaust forms a cloud. That doesn't make a lot of sense to use c there. So velocity of the exhaust, as shown, 2.8. So the last thing we have to find is that mass ratio. Did they tell us the mass ratio for this rocket? What is it? Yeah, it's 25. So all we have to do is punch this in and see if it's 7.7 or higher. If it is, then yeah, this can reach orbit. I was talking about in that movie, the lady that was doing the calculations, she would already have it at this point. She just in her head. No calculators back then. She just knew the number. There it is. So this rocket, let's go 8.03. After all, it is rocket science. We can take an extra decimal. And that was in, what was the label here? Kilometers per second. So if the cutoff is 7.7, is this going to make it? It is. 8.03 is greater than 7.7. Yes, it'll make it. Now, things that are going to affect this. If they have to put another piece of equipment on it, then that's extra weight that the rocket has to carry. If they figure out they need more fuel for what they're going to do, well, that's extra weight the rocket has to carry. So all these calculations get redone again and again and again to figure out whether or not they're still going to be able to make orbit. So 4A says a booster rocket for a spacecraft now has a mass ratio of only 15, an exhaust velocity of 2.1 kilometers per second, and a firing time of 30 seconds. Can this one make it? Well, got that same formula. You just have to get everything where it's supposed to go. So let's see. The nasty formula was V equals negative 0.0098. And then we had T plus C ln R. Use a capital R, lowercase. All right. So let's figure this out. Did they tell us the time that we need? What's the firing time? 30 seconds. Okay. 0.098. One more zero. All right, C, that was the cloud, which is the exhaust velocity. What's that one? 2.1. And then R is that mass ratio, what they say it was, 15. So let's see if this rocket's going to make it or not. Negative 0.0098 times 30, and add 2.1 ln of 15. Uh-oh. 5.39. Cutoff was what? 7.7. Not going to do it. 5.39 is less than 7.7. It's not going to make it. It's not that it might not make it up a little ways, but it's just not going to make it out of orbit. So B says, suppose your rocket, all designed, is not providing enough velocity to achieve a stable orbit. It asks us, could we make alterations to the rocket to make it happen? And what can you do? I want you to think about that for a minute. Then I want you to talk to a chicken wing elbow partner and see if you came up with different ideas of how to try to get the rocket to go up in orbit. We have no ideas? What could you do? Give me something that might change the situation. Less fuel. You could use less fuel. You might not be able to make it out of orbit, but the fuel weighs something. So you could try less fuel. What else could you try? Unload something. Decide there's something that you don't need on the rocket. You know, if you make it lighter, maybe you got a bunch of moon rocks that you're supposed to take out there. Well, get them off. Now, could we also say, use more fuel? We could, because it is possible that if the mass ratio is small enough that putting more fuel in it might give you a higher exhaust velocity, and just maybe that might work. Lots of different things they could try. And that's what happened when they were trying to figure out how to get to the moon. They just tried lots of different things. You know, if they took something off, they tried to replace it with something that would also work but was lighter so that they could try to get it to stay up in orbit as they went through those things. Obviously, they had to make those decisions immediately, but very cool that we get to see just a little touch of that. So, what we're going to do now is I'm going to give you a little baby assignment just to finish this up. Right there. But we're not going to work on it right now, because what we want to do is start reviewing a little bit for the test. You'll have plenty of work time today. Don't get me wrong, we'll have work time today, but we need to do a little reviewing today, so we definitely have enough time to review everything we need tomorrow. Okay? So write that one down. When you get these, I want you to rip off the front page and then send the rest of the test back up to me. The front page today, yeah. I just don't want any overachievers, and I know I have some overachievers in here. Working through the whole thing tonight and doing it wrong, and then remembering it that way. Right, so rip off the front page, keep the front page, but send the rest of it back up, please.
I know, me too.
All right, now put the calculators away. Put the calculators away. That first page will be a non-calculator portion of this test. You will not be allowed to use a calculator for the first part of that test that you see right there on that front page. So that means we have to use our brain power. Brain power. All right, you ready? Okay, notice the instructions. Evaluate. That means we're supposed to come up with a number that says. Evaluate each logarithm. Do not use a calculator. I'm going to be taking the calculators from you. Jesus. Well, don't call on the Lord. He's got a lot of big things to do. All right. Now, show your work. If you looked at this and you said, I don't know, you actually just helped yourself start to solve this problem. We don't know what it is, right? How do you solve logarithms? You snail shell. Now, it may take you a little bit, but I'll bet in your head you could say, okay, 3 to the first is 3, 3 squared is 9. No, after that you're done. After 3 squared, you're not going to keep working. What's 9 times 3? That's 3. So we put a 1 in here, wasn't enough. Put a 2 in here, not enough. Put a 3 in there, we've got it. There it is. Now, after you do a couple of these, you might not need to put the equals x up there anymore, but it did say you have to show your work. So you should put the equals x thing up there anyway. All right, so let's go to number 2. Ooh, fraction 1, cool. Logarithm base 1/3 of 1 over 81. But it is a little tougher, so we probably better put the equals x and do a little snail shell. So something doesn't change. What doesn't change from left to right? What's the one thing you see in 1/3 that you also see in 1/81? Well, 1. We're not dealing with 1. We're trying to figure out, raise 3 to some power and get 81. All right, what's 3 to the first? 3. 3 to the second? 9. 3 to the third? 27. Well, if you don't know what the next one is, then you say, okay, let me write this down. 27 times 3. Oh, look! It's going to be 4. X is 4. And yes, for some of them, you'll probably have to do a little math off to the side. You'll be fine. All right, number 3. Ooh, ouchie, wow, wow. Let's look at that one. Did we get a change to 256 on that copy? Everybody have log 4, 256? Okay. For the x equals 256. This could take us a little bit. 4 to the first. 4 squared. Now it gets tougher. 4 to the third is 64. Now if you didn't know that, you just take 16 times 4, you get the 64. Now my guess is we're just going to need one more, but let's try. There we go. So 4 to the first didn't work. 4 squared didn't work. 4 to the third was 64. It didn't work. We had to go to 4 to the fourth. But this is math. You can certainly, we're capable of it. It's just multiplication. We can do that. Number 4. Log base 64. Ooh, that gives us a equals x. 64 to some power is 1/8. Ooh, that was tougher. What kind of power takes things that aren't fractions and makes them fractions? Negatives. Then we have to think, what do you do to a 64 power-wise that would give you an 8? Think powers. In this case, you need to think undo powers. Square root, okay? So square root, how do you write square root as a fraction power? It is 1/2. Square root is 1/2. That is a negative 1/2 power. So when a number is larger and it gets smaller, you have to think, okay, it could be square root, which is 1/2 power. It could be cube root, which is 1/3 power. And you just go through the list until you find what you need. Hey, put that calculator away,
You
cheater!
get 0.125 if you do negative 1/2. How is that right?
64 to the negative 1/2.
It's not 8. It's 0.125.
Hit math. Number 1, enter. See, again with the Lord. You're responsible for this, not him. All right, let's go after number 5. All right. It was a fraction, now it's not. How did it get flipped? What power flips stuff? Negatives. 2 needs to become 32. Think through it. Tell me what you get. 2/5. 2 to the first is 2. 2 squared is 4. 8, 16, 32. 5. Well, it's okay, it's not gonna be erased, so you'll be able to write things down, take as long as you need for that portion. Because you get a calculator for the other two pages. Alrighty, how about 6? We have, logarithm base x. X to the 7. Believe it or not, you're already supposed to be done with this one. What does it say? If this base matches this base, what happens to all of this mess in front? It says 7. It says 7. So, let's see, should we go a little farther today? Let's at least try to get through 9. So let's do 7, 8, and 9. Solve each equation. And now you can grab your calculators. Yeah, you'll get your calculator back for these. All right, here's what we need to do. We need to get this little bugger all by itself so we can solve this. So what do we do about the 12? Subtract it. Even the negative can't be in front of it. So how do you get rid of the negative? 5. Now, you're going to have your calculators back. So you wouldn't have to do this in your head, but didn't we already do this one earlier? What is it? It's 3. Now, if you forgot, here's what you do. You say to yourself, hey, I have a calculator. I could take the logarithm base 4 of both sides. And then you could punch in log of 64 divided by log of 4. You're still going to get 3, either way. But because we had seen this on the first page, you probably would just go from this step immediately to base 3. Get it on there. Alrighty. Number 8 looks a little more challenging. Log of 500 minus log of x equals 3. We got a snail shell, but in order to snail shell, that has to be log. Not 2 logs, log, blah, blah, blah. How do we get that to not be 2 logs? Divide, exactly. Subtraction in logarithm language is division. Now it says LOG, there's nothing in front of it, so we can snail shell. But we need a base. It is 10, exactly. If there's no base there, it's a 10. When it says LOG, it's base 10. So it'll be 10 to the 3rd equals 500 over x. Now, 10 to the 3rd, you could grab your calculator, but it's going to be 1,000. And I keep thinking if I could just throw something underneath that 1,000, I could cross multiply. Yeah, 1. So 1,000x equals 500. Then what do you do? And it reduces to a very lovely 1/2. There it is. So logarithm. If there's 2 of them, condense them, and then snail shell. How about number 9? What do you want to do? Are there multiple logarithms? Do we have to put them together first? So then how do you solve logarithms? You snail shell. Yeah, again, fancy name for it in the book is going to be exponentiate, but we're not going to call it that. We're just going to snail shell. Read the board, you grab your calculator. You get 81. And then how do you get x by itself? That's 7. And there it is. Now let me take a quick peek, but I think we're going to have more than enough time to. Oh, you know what? Oh, we've got the tornado drill stuff tomorrow. So let's triangle a little farther. Let's do 10 and 11. That would be best.
Let's just cross it out.
No,
No.
can't cross them out on the test.
Red.
All right, enough with replay numbers doing it. Now what? Divide by 3. Just yesterday, we solved these. How do you get rid of that E? LN, exactly. And what you do to one side, you have to do to the other. Not going to punch it in just yet because we've got one last step to show, right? What do we have to do? Divide by 2. Remember, you're going to punch in natural log of 8. You're going to finish off the parentheses, and then you're going to divide by 2. And with these, 4 decimal places is the standards. Let's see what we get. Well, on helps. So 1.0397. And checkable. Toss it back in for X and make sure everything's going to work. All right. Number 11. Thoughts? Subtract 6. Yep. Next. Divide by -3. Right, we need this logarithm thingy all by itself. It's a logarithm. How do we solve any logarithm? We snail shell. So we need a base. What's the base for ln? E. So let's rewrite this so we can snail shell. And yeah, we definitely need a calculator for that. So second ln gives me the e to the -1, 0.3679 with rounding. Well, now I know for certain we'll be able to finish the next ones, even with the drill and lockdown drill stuff that's going to go on tomorrow. So you have a little teeny assignment to cover our rocket science stuff that we learned today. But I'm also going to give you the review for the test. And you're just getting one assignment over the 2 days. So after you finish that little assignment for 7-6 day 2, you should start on this little baby right here. Don't do the whole thing, otherwise you won't have any practice to work on to the test stuff right. Alright, so this is my suggestion. If I were you, I would finish up that little 7-6 assignment, and then I would just do everything on the line that says chapter test, page 491. And then I would stop. Because that's what we reviewed today, was that stuff. Chapter test, page 491. Notice there's a no calculator part, and then it's a calculator